Aloha, namaskar, and hello. This is Climate Change Beyond Outrage. In it, we go beyond outrage to focus on solutions to climate problems facing people, nations, and the world. I'm Anu Hittel, and I'm broadcasting live from ThinkTech Studios in beautiful downtown Honolulu. So to join that live conversation, please tweet us at ThinkTechHI. And while we're on the subject of tweeting, what I would like to do, actually it's pretty appropriate that we're talking about tweeting because it's about birds today. But on the subject of tweeting, what I would like to do is to ask you the question, what in your lifetime have you seen as a climate shift? Not a one-time event, not a tsunami, an earthquake, a climate event, something like you've been skating on a particular pond for the last 30 years and then the last 5 you haven't been able to do that. So please tweet that in and I will read those tweets out in the second segment. Today our episode focuses on seabird conservation and climate change, and I have a very special, vibrant and talented guest with me in the studio today. David Hyrenbach is here from Hawaii Pacific University. He is Associate Professor of Oceanography. Welcome.
Thank you very much.
It's nice to have you. And so we will talk a little bit about seabird conservation from Tasmania to the Arctic, and we will also cover some regional ground here and talk about seabird conservation in Hawaii, climate change effects and what we're seeing, and why that's important to humans. So David has a background. He's Associate Professor of Oceanography, and he has a background with research interests in marine conservation, ecology, and natural history of marine megavertebrates, which I'm told tuna and big things like that, not anchovies, right?
Not anchovies, seabirds, marine mammals, turtles.
Okay, and he looks at seabirds as bioindicators. Yes. So seabirds are an indicator of ocean health and climate change, and they're extremely sensitive themselves to changes. And I know that a University of British Columbia study has come out with, showed that of the monitored seabird populations around the world, that seabird populations have declined 70% since the 1950s. And there are other sorts of trends we're seeing in habitat, because of habitat loss perhaps, or because of climate change. I know these are not all due to climate change. There's also a certain amount of mismatch, and that's something that you and I will talk about a little bit, where when seabirds come in or they leave a particular place, they need food, and that food has either already come and gone because of climate change or it hasn't showed up yet, right? So recognizing that these are not all due to climate change, how closely does your work mirror some of these reports and these studies?
Well, I really want to highlight what you've said. It is undeniable that seabirds are having a really tough time globally. And IUCN, BirdLife, all these organizations that compile data can provide evidence, irrefutable evidence, that populations are by far declining. Yet there are some very happy stories. There's places where people have taken a proactive stance to restore breeding areas, to protect seabirds from predators, to make their lives better. And some populations are increasing.
Well, that's good to know.
Yes.
And of course, some of those efforts are happening right here in Hawaii, and we'll talk about that in our second and third segments. Okay. And so tell us a little bit more about your work and some of the things that you have been seeing. We've been working with Shearwaters.
Yeah, my work has really emphasized the use of seabirds as indicators of changes in the ocean. Changes in the productivity in the ocean, in the climate of the ocean, in the overall structure of all the food webs that support seabirds. And shearwaters in particular are a great vehicle for that.
So we're seeing a slide here of your lovely little short-tailed shearwater.
Yeah. So for this first example, I'm going to take you on the back of short-tailed shearwaters that breed in southern Australia and Tasmania, at the very bottom of the range map shown right now on the screen.
So that's the green areas.
That's
right.
That's
how far it flies, from Tasmania up to the Arctic and then back again.
Yes, that's right. During their southern winter, our northern summer, these birds migrate across the Pacific They go all the way into the Bering Sea, and now they're moving north of the Bering Strait.
Okay.
They spend the summer at these very productive areas. They fatten up, they molt, they change the flight feathers, and then they fly back home to reproduce.
So it's a little bit like the whales that are migrating as well. I mean,
Yes.
the whales are not flying, but
That's right.
but they're also migrating up to the productive waters, and then they're coming down here
Yes.
and going back again.
Definitely. They are taking advantage of this very localized, very high, rich feeding areas that they find at high latitudes in the Bering Sea. So maybe we can look at the next slide for a second, because I want to really highlight, that this is a map showing you where short-tailed shearwaters are found in Alaska. You see the Gulf of Alaska, then the Bering Sea north of the Aleutians. The bigger the red symbols, the more birds you find in those areas.
So most of them are concentrated there on that yellow.
That's right. I'm
area.
highlighting that yellow area because that's the area where we know vast numbers of them aggregate. This is called Bristol Bay, the southeastern Bering Sea, very productive fishing area, and really the restaurant for the summertime shearwaters that come here.
So maybe you have some kind of a picture of how many. I mean, when you're talking
Yes.
about mega flocks like this.
This
right?
is a mega flock picture at Unimac Pass, one of the places where predictably short-tailed shearwaters in the hundreds of thousands, even in the millions, aggregate. You see there's white little footprints amidst the shearwaters. Those are humpback whales.
Oh.
So this is a multi-trophic restaurant that gets set up over here. And again, vast numbers of these birds.
When you talk about vast numbers, are you talking thousands, 10,000s, more,
Well,
millions?
there could be some of these flocks that people have estimated reached up to 1 million birds. About 2 to 4 birds in a meter squared, tightly packed, and you're seeing birds in all directions as far as you can see.
Right. So obviously you have to estimate these, and this is harder to estimate in the open sea versus on land.
That's
for
right,
example.
very
Right,
hard.
Right.
But we know, even knowing how many short-tailed shearwaters there are, we have a sense there's about 20 to 40 million.
Okay.
So there are a lot of them, and sometimes they become very aggregated in some few specific spots.
Okay.
Yeah, so this is the restaurant. The important thing is you want to show up when the food is ready for you to show up. So as you can imagine, the shearwaters don't know what's happening in the Bering Sea. They're flying over, and the timing is such that when they arrive, the food web has matured and they have the right kinds of foods that they need. Little euphosid crustaceans, little shrimps, krill. Maybe we can look at the next slide for a second. This has been happening as far as we can tell, this matching of the shearwaters coming to the Bering Sea and finding the table has been laid, right? Laid down for them to eat. The restaurant is set up. However, in 1997, I was on a research cruise as a graduate student up in the Bering Sea, and we encountered very unusual conditions. This map shows you a satellite photograph of this southeastern Bering Sea area. Green is phytoplankton. This is a large bloom of phytoplankton. You could think phytoplankton is a good thing, is the base of the food web. Yes, but the food web that leads to food for shearwaters relies on diatoms, big cells, very productive big cells of phytoplankton. This year we had a bloom of a very unusual subtropical species, a coccolithophore.
So it's a different kind of phytoplankton.
Completely different phytoplankton.
Nothing that they eat.
Nothing that they eat, and nothing that their euphosid shrimp prey can eat. So when the shearwaters arrived, the euphosid numbers were really low, they were not mature, they were not spawning at the surface, which is what they need, with the prey they're really targeting.
You're used to eating pasta and suddenly you're faced with lentils.
That's right, or even worse, you're used to, a nice a plate of pasta, you show up and there's just a little bit of crumbs. So you have to deal just maybe with the olives and a little bit of the side hors d'oeuvres and try to make a living that way. So this particular year, the shearwaters were eating very strange foods. They were eating crab larvae, for example.
So then it would have an effect on other things that are going on because they're foraging for something different.
That's right, that's right. And also if you think about these euphosid shrimps are also the prey, for example, of the salmonids, the salmon that are harvested in this area. So there wasn't food for shearwaters, but there also wasn't food for salmon this year. So if we can look at the next slide, just to show you the obvious thing that you can imagine, there wasn't food around, so we documented a large die-off, a large mortality event. We went to document living shearwaters, thriving foraging shearwaters. We ended up counting a lot of dead shearwaters. We estimated, here you have some pictures of shearwaters washed up on beaches. There were surveys done throughout the area that estimated about 400,000 of these birds washed up dead on the beaches. We counted about 200,000 more that we found floating at sea. But you know, you could say, well, you just told me there's about 20 to 40 million, 600,000, that's, you know, well, it's too bad, but it's not a really big deal. But actually, we had additional evidence that suggests this was actually much more of a dire problem. This is a bit of a complicated graph, but I just want to walk you through it. There's 3 color bars that show you the percent of fat that a given shearwater had in its body mass. And you see there's different categories on the x-axis, on the horizontal plane. Bigger numbers means more fat, more healthy shearwaters. Well, if you look at the first color, spring 1997, the shearwaters have just arrived from Tasmania. Some of them have as much as 25 to 30%. You know, on average, they have about 15% of their body's fat. At this time, they have just completed their migration. This is the time when they fatten up. They change their feathers. They're really gaining mass and gaining energy stores. This is not what happened in 1997. Usually those bars would move to the right. Instead, you see they moved to the left. There are those white bars with the black diagonal lines. Between the spring and the fall, the birds got skinnier. They lost mass.
So that's what basically you're saying, that they're starving.
That's right. They were starving.
Because their table was not laid.
Yes. And it wasn't that there was toxic dinoflagellates or anything. No, they were actually starving.
Okay. And so what about this? Sometimes people will say, oh, there are birds that wash up on the shore and sort of things like this one here in Tasmania. You know, the Sydney Morning Herald sort of says there are 10,000 shearwaters washed up in Tasmania. Is that part of the phenomenon that you were talking about?
This is a different phenomenon. There are occasional die-offs like this. Usually they entail young birds. You know, they're hatched, they're fed by their parents, and then they have to go to sea for the first time. And this is really a difficult time when a lot of birds perish. So these events, you know, maybe they're increasing in frequency. We must look into this, but they're not that serious at the population level, because what we saw in the Bering Sea killed both young and old mature birds.
So that is much more serious, and you're really looking at ocean changes when those changes in food happen. So that's really sort of the big things that you're following and monitoring.
Exactly.
So at this point, what you're doing with that is you're monitoring those changes, you're recording them, observing them, and you're looking at the dead birds, what kind of fat content, what is happening, and trying to put a puzzle together.
That's right. Basically, try to solve a crime scene, and beyond that, trying to figure out, is what happened in 1997 a strange, one-in-a-lifetime event, or is this the first instances of the new normal, or the first instances of something that is going to be much more frequent?
And what's to come.
That's right.
And that's something that we will come back to from the break. So don't go away. When you come back, hopefully you'll have tweeted up a storm, no pun intended, and we'll see you then. So stay with us.
Hi, I'm Donna Blanchard. I'm the host of Center Stage here on Think Tech Hawaii. I hope that you will tune in and watch the show. It is inspiring and uplifting and educational also. We talk with artists of all different ilk. We talk with them about what they do, how they do it, and most importantly, most dear to my heart, why they do it. And it never ceases to be fascinating when you get the answer to that question. I hope you'll join us on Center Stage, 2 o'clock Wednesday afternoons. Aloha.
Hi, I'm Jay Fidel. That's Ted Ralston. You know, Ted is the host of Where the Road Leads. It shows every Friday from 4 to 5 p.m. It's about technology. It's about how people collaborate and solve problems with modern technology. It's where the road leads. We all know that. We should all be listening. Join us there, 4 to 5 p.m. every Friday. Now, what about that do you agree with?
All of it.
I knew he'd say that. Aloha. Say aloha.
Aloha.
Good.
Oh, yeah, sure.
Welcome back to Climate Change Beyond Outrage, where we talk about solutions to climate problems facing people, nations, and the world. And today we have David in the studio with us talking about seabirds and what's happening. How do those impact us, and how do those currents and the changes in the oceans impact the seabirds? So we just finished talking about short-tailed shearwaters in going all the way from Tasmania up to the Arctic, and finding that there are changes in the ocean, in the food levels and so on, and the composition of food. What that does to the shearwaters essentially kills them. And then now we're talking about another phenomenon that David has observed in California.
Yes, I think the first example illustrates effects on single species, again, trying to solve the riddle of why these die-offs happen. The next slide illustrates a similar scenario, but now we're going to look at a whole community and how all the species change. This is a picture from Monterey Bay in Central California, a large flock of sooty shearwaters close in off Capitola Pier. These types of events were very common when you talk to people in the 70s, 80s. They used to see big flocks of these birds around. But now when something like this occurs, it makes the news because it's sort of an unusual event.
It's beautiful.
Very, very wonderful. You know, huge flocks of these wonderful shearwaters that migrate from New Zealand and Chile to California, again, during their winter, our summer.
So they're going some pretty big distances here.
Yes,
they're
very,
going all
very
across
big.
the Pacific Ocean, only sort of sideways, not sort of east to, no, it would be west to east.
Yeah, there's this sort of figure 8 pattern that's Josh Adams and other colleagues have documented with satellite tracking. So truly magnificent animals. So remember, in the previous example, we just had one event. We didn't have the time frame to consider what has happened over time. So this example I'm showing you here actually is wonderful because it really illustrates why we need long time series, why we need large amounts of data to try to make sense of those rare events and really be able to assess whether there is a new pattern emerging or are there really unusual conditions.
Right, and this is a video that we can't really show because of various reasons, but we just wanted people to be able to look this up to get an idea. Just if you Google swarm of sooty shearwaters, you'll just see that there are birds and birds and birds. And maybe you want to talk a little bit about how, you know, when you were telling me that when you go in to the lab for lunch or when you come out, maybe you want to talk a little bit about that.
So you mentioned situations where we have in our lifetime felt some of these changes. I remember being in Moss Landing Marine Labs, going in the morning to the lab, and there was a stream of shearwaters going by, just like in this video. You know, okay, the shearwaters, we go in, we're working, we come out for lunch at noon, the shearwaters are still going.
They're still flying.
Still going. Then you go back in, keep working, you come out in the evening, they're still going.
Incredible.
So some of these, again, just massive flocks and aggregations that really boggle the mind. But yet you talk to some old-timers and they say, no, yeah, this was commonplace, this was not unusual. And now when they happen, you know, everybody gets very excited because it's a rare thing to see.
So this is something that's changing, and I think you've done some work around how much and so on. So maybe if you had brought some slides in.
Yes.
So maybe looking at that slide of the current and how it's been warming, there's some evidence here that you yourself have seen.
Yeah, this was a big time series that we compiled from 87 to 1999, 12 years. And basically I want you to see that on the left, water temperature increased. The red line's going up. The ocean at 100 meters deep in Southern California has been warming. And then on the right, you see that overall seabird abundance has decreased. And back in the 70s and early 80s, the sooty shearwater was the dominant species, the #1 most numerous species in this particular community. And through this period, they really disappeared. They declined in vast, vast numbers.
And so this is going on, this time series you said is taken from 1987 to 1999.
Yes.
Okay. And that's one of the things I think to emphasize is just to look at patterns and rather than events, right? So you're looking
That's
when you're looking for patterns, you're looking for something over a period of time. You're not just looking at a one-time event. The one-time event may affect that. For example, this is my favorite topic in the world, is about El Nino. So, you know, a lot of us have heard about El Nino, and, you know, tell us a little bit about how does that affect. Tell us first, you know, what it is, because there are some people who still are a little fuzzy about that. And then how does that affect your observations, and what do you do about that?
Yeah, so El Nino, is basically a concurrent changes in the atmosphere, in the winds, in the surface currents, in the temperature of the ocean, and the vertical structure of the ocean. How deep are the nutrients? How deep are the productive waters? This happens throughout the Pacific Ocean and is really felt in the tropical band, is where you feel the sort of the starting evidence and really the most striking effects.
And that's something that happens about every 2 to 7 years or something, they're saying?
Yeah.
And this is an El Nino year,
Right
we've
now,
established that?
Yes, we are on an El Nino year. You know, we're increasingly able to predict these events using a series of buoys that are deployed throughout the equator in the Pacific. Yet, we're not as good as predicting the duration, the longevity of the events, how long are they going to last, and then what happens after. Does the system bounce into a La Nina event where we have a complete reversal of the conditions, more trade winds, cooler water in the east, and so forth?
So what does that do for your observations when you're monitoring these birds and so on? I mean, and I guess that.
So
yeah.
You know, it really mixes the situation, mixes up the patterns, right? Because often we're so focused on these higher frequency events, El Nino, La Nina, 2 to 4 or 7 years, that we tend to forget that there are other cycles that take a lot longer underneath, like the Pacific Decadal Oscillation, about 30 years, and then there's global warming underneath. So I think we sometimes forget that just because it's an El Nino, it's not going to be one particular way. Well, it depends on the synergy of El Nino and the phase of the PDO, and then the global warming happening underneath.
The PDO is the Pacific.
The Pacific Decadal Oscillation, which is sort of a much longer, slow frequency type of an event.
Right, and so when you looked at some of the warming impacts from this California current, so those waters are now becoming warmer.
That's
Obviously,
right.
you're going to see a species composition change. So there'll be different species coming in, different things growing, different things feeding, right? So I think you had, at one point, you had a little drawing of pie charts that showed what...
Maybe we can look at the next one. Yeah, this is a way to boil down all that information. Remember, we had 12 years of data. We can compare the early 87 to 90 against the late 95 to 98. And two things I want to convey here. The first one is the pie represents the abundance of seabirds in the California current, in the Southern California current. Between the late 80s and the late 90s, the pie decreased, and now it's 45% the original size.
That means it's the number of birds
That's
has
right.
decreased by 45%.
The abundance, the density of birds in the ocean, all species combined went down.
Wow, so there's just that much fewer birds.
That much fewer birds. But not only that, you see, I have color-coded the different pieces of the pie for the ones that like warm water, the more tropical species, the ones that like colder water, the more subarctic species, and then the ones that don't really show a clear preference, depicted by white. Well, as you can notice, the pie got smaller, but the amount of red in the pie, the flavors of the pie have shifted. A lot less blue, a lot more red. So again, we have an overall change in the abundance and also a shift in which species are now the more numerous ones, which species are coming into an area, which species are leaving the area. So it really suggests, again, one single species pattern could be an oddity, but when you're able to look at entire communities and build pictures like this over time, combining responses of different species, it becomes very clear that there are striking climate influences.
Right, and so this again reinforces the the power of observation over a long period of time. So it's difficult to say what's going to happen just based on one single event or two single events. You really want to be observing over time, and that's something that we encourage people to do, just look around them. And I have two examples. I didn't get in any tweets yet, but ahem, tweeters, come on. But I did get a couple of folks telling me on social media. Holly in California wrote in that her gladiolus from South Africa flowers earlier and earlier each year now. So what used to flower in January is now flowering in November. So we're seeing these patterns on land as well. Cindy in Missouri says the sugar maple in front of her house used to reach its peak color by October 15th, even 10 years ago. In the past few years, it's still green October 15th, and it's shifted to about mid-November, the peak. So all of these shifts are happening. And so that may be something that is kind of an interesting phenomenon that you observe a lot in your impacts. But let's go a little bit, before we talk about the mismatch and so on, let's talk a little bit about the impacts that our Hawaiian birds are feeling and what we're seeing here on the Hawaiian Islands compared to that big region that you just talked about.
Yeah. So undeniably, the big emphasis here in Hawaii, because we can see it very clearly, are the potential impacts of sea level rise. And there's been a lot of work done, some reviews done about these issues. I'm showing you some pictures here of the Northwest Hawaiian Islands. These are flat atolls, very low elevation, very susceptible to sea level rise. Maybe we can look at the next slide. Very recently, we have documented changes in some of these features which really are expected to change shape and size, emerge, disappear. We know this is a very dynamic system. This is a picture of Whale Skate Island in French Frigate Shoals. It disappeared in the late 1990s.
And is that unusual? Because you're saying it's very dynamic, so do islands just disappear like that? Or
yeah,
they do?
They disappear. And this is just to show you that, again, one event, a little island disappears. Well, is this a model for what may happen in the future? Is this just something natural, part of the system? Without observations and data, it's very hard to interpret this one single type of events.
Right. And so when you're looking at sea level rise in these areas, what you've done a study on this, and or rather, it's not that you've done a study, but there have been some studies done on this. And what are we finding from that?
So you can see this is a picture, two graphs from a Baker et al. Study from NOAA, researchers concerned about monk seal pupping areas. And basically what we show here on the horizontal axis is the elevation, the number of meters above the average mean sea level. And then on the Y, or the vertical axis, is showing the proportion of the area of the island that is above that elevation. So for example, if you follow any one of those lines, they all start at 0 meters and 1, which means that when you are at 0, which is the mean sea level, all of the island is above sea level. Okay, then what happens as we dial and start increasing the amount of sea level? So we increase the elevation. So then you see as we go from 0 all the way to 3.2 meters, the amount of area of the islands goes from 1 to 0. Basically, as the sea level goes up, the area of those islands is going to diminish. Some diminish faster than others, but you see that all the lines are going down to 0.
So meaning that as sea level rises, you're going to obviously lose some of these islands. You're going to lose some land. You're going to lose some coastland. And this is something we talked about last week in last week's episode as well, looking at sea level rise specifically in the state of Hawaii. The state is doing an assessment as to what areas will be vulnerable, and so we're looking at that. But you are looking at what impact this has on your seabirds. Well, yours and ours.
Yeah. Again, this is a place where we can really see the potential effects. So we map the areas, there's been all these studies happening. I also would like to highlight something that happened a few years back, if we can look at the next slide, just to highlight again that, you know, there's these trends, these models that can be linked with climate change models and so forth, but then there's other events that can happen superimposed on these trends. So this is a sort of a natural experiment that happened in March 12, 2011. There was a tsunami inundation that happened on Midway, shown here. And what this is showing you basically is, if you look at the area between the two red lines, all those areas were inundated by the sea.
And so what happens when that gets inundated, and I think you have another slide after this one, if we can see that, that's the effect on the albatross, right?
That's right.
And so even though this may not be climate change related, or it may, we don't know, but even though it's not necessarily climate change related, it is something that this is the effect that sea level rise would have on these birds, right?
Yeah, you can see in this case, the tsunami was not climate related, but it could be a proxy, it could be an example of what if on top of the increasing sea level, we had more storminess, more wave events, more of these things happening on top of other things. And in this particular case, it had drastic effects on the albatrosses.
And we'll talk more about what we can do about this when we come back from the break. How do we manage for sea level rise for these birds? Is there anything we can do? So stay with us and we'll come back and talk about that.
Aloha! Hello, my name is Patrick Bratton. I'm host at Global Connections here at ThinkTech Hawaii. We broadcast live every Thursday at 1 p.m. We bring Hawaii to the world and the world to Hawaii, talking about international events and various things of interest to the audience. Please join me. I look forward to talking with you and having you get to meet some of my guests. Aloha.
Hi, I'm Donna Blanchard. I'm the host of Center Stage here on ThinkTech. This show is so very dear to my heart. We talk with artists of various different ilk here about the process that they go through for their art. So we talk about what they're doing, why they're doing it, how they do it. And it's a show that is inspiring. This is what I hear from people all the time. And a show that will teach you something, sometimes something about yourself. I hope you'll join us. The show is Center Stage. It's on ThinkTech every Wednesday at 2 o'clock. We'll see you then.
Aloha! How you doing? It's me, Angus McTech, wishing you to welcome and join us to see us on Hibachi Talk on ThinkTech Hawaii. Join my co-hosts, Gordo the Tech Czar and Andrew the Security Guy, every Friday from 1300 to 1345. We look forward to seeing you. We'll talk tech and we'll have some wee bit of fun. And remember, let your wing gang free wherever you be. Aloha!
Aloha and welcome back to Climate Change Beyond Outrage. I'm Anu Hittel and my guest today is David Hyrenbach from Hawaii Pacific University, talking about seabird conservation. And we were just getting into the effects of sea level rise on seabirds here in Hawaii, especially the northwestern low-lying Hawaiian Islands, and what can be done about them. So let's go to our slides about and perhaps you want to just put in a plug for what's going on.
Yeah, definitely. If we can see the next slide. Well, there are a lot of people working really hard to come up with creative solutions. And one of the creative solutions is translocating some of these seabirds to higher islands that will be impervious, will be more resilient to this sea level rise. I hope your audience knows this place here on our island of Oahu. This is Kaena Point, a beautiful area protected from predators where albatrosses and shearwaters and endangered Hawaiian plants thrive. So a lot of this work is happening, again, trying to anticipate the move, the needed move of some of these species.
So when you're saying translocation, are you actually moving birds, or is it establishing new colonies, or is it pretty much the same thing that I'm talking about?
There's different approaches. Some approaches attempt to attract birds to areas so they can breed. They have decoys, for example, or they can have sounds of adults displaying to attract new birds to breed. In other situations, the approach is more intensive, and it actually entails moving young chicks that are hand-fed, fostered, and then they will leave, and hopefully they will return back to this location.
So that's one of the things that's happening, is trying to look at
Yes.
how do you move these birds, how do you form new colonies for the time when these islands will be inundated, and millions of seabirds are at risk.
Yes.
Right. So and then you had another slide.
Yeah,
where-
this is a funny slide. If we can see this, this is something that Beth Flint, who I know is coming to your program,
Yes, in
a
2 weeks.
wonderful seabird biologist and naturalist, brought up once at a meeting. She said, well, you know, maybe we gotta think about some other technological fixes. Maybe we can make some fake islands for these birds to breed on. And she said, you know, an aircraft carrier would be a great platform for albatrosses, perhaps. So
Right.
maybe we can start parking them up there somewhere.
I'll see what I can do.
Yeah.
I'll get my friends at DoD to do that. Yes, to come and park up there.
Yeah.
So let's shift gears a little bit and talk about the challenges that these birds face on the Hawaiian Islands. But what sorts of challenges do they face out at sea?
Yeah, you notice all this discussion was focused on the colonies. So now for this part, I'm going to put on my bird hat because this part is really much more difficult to grasp.
Ah,
You can see.
what do we have here? We have a David with a.
This is a Laysan albatross that my mom made for me,
Aw.
and I use it for special occasions. So yes, to understand how birds at sea here in Hawaiian tropical oceans will respond to changes in climate, it is fairly challenging. So that's why, again, we can talk about things we're observing or predicting, but there's a lot of moving parts and interactions with tunas and marine mammals, and it's going to be a lot harder to really make solid predictions of what's happening. That's why I think we need to think like a bird.
All right. So when you've been thinking like a bird,
Yes.
what have you found?
Well, let me show you first some evidence of possible changes that are happening or we think are going to happen. If we can look at the next slide for a second. This is a map from NOAA, again, looking at satellite images of chlorophyll, the base of the food web, how much productivity there is in the ocean. Again, comparing changes over time. So I want you to see, again, we're comparing 98, 99, 2005 to 2006. Areas in red are places where we had low productivity, lower than that value of 0.07, only during the late part. And you see those areas are to the east and sort of creeping up to the north towards California and Southern California and Baja California. Then we have areas where there's been no change, in gray, this big blob in the center, and then areas where there's been actually an increase, they're sprinkled throughout the edges mixed with the red. But again, this paper and this work really suggests that the low productivity areas in the tropics are expanding and becoming larger and moving to the east and to the north. Birds that need to feed on that more productive water are going to have to go further away.
I'm going to just quickly read out a tweet that's come in,
yeah.
and it says, it's from Harrison in Missouri. I think you know who that is. Hi, Harrison.
Thank you.
And he says, I was wondering what the community could do to help the shearwaters and curb the environmental problems.
Well, the shearwaters, they really need help on land. Things like making sure your cats and dogs don't go into colonies and kill or injure birds is really important. Things like making sure at the time when the shearwaters fledge in November, early December, you keep lights shielded, especially if you live in areas close to colonies, you make sure you don't have light pollution sources that will attract the birds in towards the structures and lead to their injuries.
Okay.
Those kinds of things, you know,
Okay,
and
good.
in general being aware that, you know, they're out there, they live among us and they make a living in the ocean,
Yes.
like many people do, so.
And so let's go back, thank you Harrison for that tweet. Let's go back to what you were talking about with the changes in wind patterns and tuna distributions and all
Yeah.
those kinds of things as well.
Okay, so productivity is going down. What else do we know? Well, there's suggestions that the wind patterns are going to change. You see here a map of the big high pressure systems, the trade winds north of the equator. That's where we are embedded. there's predictions that the trade winds are going to decrease in intensity and change angle as that high pressure zone moves further to the north. Also, if you have been here, were here last summer, you noticed a lot of storms, a lot of hurricanes and tropical depressions and storms coming by. There's suggestions these may be more commonplace events during summer, during the breeding season for a lot of these birds, and they may bring a lot of rain and runoff and other impacts on them.
Okay, and so you're seeing that you're seeing there are changes in the ocean. There are then going to be concurrent changes or consequent changes with the birds. And is this something that that you're studying very closely? You're looking at what it does to their weight, to their to their nesting or their reproductive success and things like that?
Yes, definitely. We are trying to build up time series so we can understand how the birds respond to changes in the ocean. Again, building up this detective story to try to understand. But I really want to highlight, and that's why this slide is up, that a lot of these relationships between the prey and the ocean and the seabirds here in the tropics are mediated by tunas and marine mammals that help the birds by bringing food close to the surface. And the models suggest some of these tunas, like skipjack tuna, aku, are going to be more abundant. They're going to be distributed further to the east, closer to our waters in this global warming ocean. So it's not all maybe bad news for some of these seabirds.
But there are changes coming. There are
Definitely
changes coming.
Are coming.
And you've been seeing these changes, and it's your job to sort of record these changes so that then you can feed it in to management decisions that, for example, biologists at Fish and Wildlife Service or people who are managing some of these reserves, they can then look at that and adjust what they're doing, right?
Definitely, yes.
Right. And so we'll need to close soon, but I wanted to just read out a quote from Rachel Carson, and it's just really more about the sea.
Yeah.
I understand it's not just your pelagic seabirds, which is the open ocean seabirds, but here it is. To stand at the edge of the sea, to sense the ebb and flow of the tides, to feel the breath of a mist moving over a great salt marsh, to watch the flight of shorebirds that have swept up and down the surf lines of the continents for untold thousands of years, to see the running of the old eels and the young shad to the sea, is to have knowledge of things that are as nearly eternal as any earthly life can be. So, and so this is something that we're trying to preserve. It obviously has a cultural component. Even here in Hawaii, you've seen that cultural practitioners will use feathers and so on for these birds, even for the seabirds, correct?
Yes, definitely. Yeah. There's very, very deep cultural connections with these birds that they're our ancestors, as everybody knows, and they're wonderful indicators of ocean conditions.
That's right.
Anybody who goes fishing knows.
That's right. And so thank you very much for helping to preserve these wonderful ancestors of ours, and for being here today, for wearing your albatross hat. Gracias a su mamá. And thank you very much for joining us today, viewers. We will be here again Tuesday at 1 o'clock next week, talking about snails on Oahu. So snails and climate change up next week. Thank you, aloha, namaskar, and goodbye.